So welcome on the last Sunday block. I'm Jan, I'm on the PC and I will be running the session. And the first talk is by Willem Toorop on seeing the effects of the Flag Day in action. So please.
Thank you. So I also have a short introduction of what the Flag Day actually is. So eDNS-0 is an extension mechanism for DNS, introduced 20 years ago in 1999 by Mr. Paul Vixie, and it allows DNS messages to be larger. Extended OARC codes is used for name server identification, for signaling, DNSSEC support, all sorts of things that were not in the DNS can now be added to the DNS thanks to eDNS-0. And it's also specified as a backwards compatible mechanism, except that in reality there are quite a few of authoritatives still, after 20 years of this specification, that if they see a query with eDNS-0 or with the extension mechanism, they just chuck it. So a resolver now doesn't know what to do. Is this a authoritative that does not support extension mechanism? Or is this server upstream, server down? So it has to wait for a little bit to be uncertain and then twice the query again, but then without the eDNS-0 option to find out. And so the open source vendors had this initiative to say, well, you know, it has been 20 years that this specification is out there. We don't have to take this any longer. So we are not going to do the workarounds anymore. We are just going to send queries with eDNS extension mechanism, and if the authoritative drops it, then it's down. If it doesn't support it, it could reply with form error, and then that's an indication that we should send without the eDNS-0 option. But not responding at all is really bad. So a lot of people participated in DNS in this initiative. It was first announced March last year. There are lots of measurements against authoritatives, what the state of the authoritatives have been made. There was a lot of outreach in this year. Lots of authoritatives got fixed, which is really good, and plenty of middle boxes as well. And so I worked together with some other people that also like to do DNS measurements, and we thought, well, February 1st is DNS Flag Day. We are going to measure the resolvers to see how long it takes before they support Flag Day and actually do no longer do the workarounds to resolve from broken authoritatives. So how did we do that? We created a authoritative name server that would chuck all queries with eDNS-0 option. So we did this shortly before February the 1st because we thought that we were measuring the uptake of eDNS Flag Day. But what we noticed was that not already was already eDNS or DNS Flag Day ready. And Power DNS also seemed to be ready. So measurements we did were from RIPE Atlas, and what we also immediately noticed, so it's a measurement that asks for this name, flagday.rootcanary.net, asks for the IPv4 address, and if it gets an answer, then it's not a DNS Flag Day ready resolver. We noticed that from the 19,000 resolvers that we can access on RIPE Atlas, 50% of them were at February the 1st already Flag Day ready. So this is quite peculiar because it's the authoritative that needed to be fixed, right? Not the resolvers. We were just announcing resolvers will do this, and then you better have a fixed authoritative. So, but we did uptake measure the uptake of Flag Day ready resolvers on Wipe Atlas, and this is what it looks like. It's now 42% from 15% at the start. And these are the ASs responsible for that. And as you can already clearly see, there's one AS that really stands out, which is Google. So here are the uptake of Flag Day of the different cloud DNS resolvers as seen on Wipe Atlas. So you can clearly see that 8.8.8.8 incrementally deployed, not responding on EDNS0 dropping anymore. Also, Quad 9 very recently, May 1st, did something to their infrastructure, and they're also almost 100% Flag Day ready now, or their resolvers. So we also did some other measurements and looked at the authoritative side. We did measurements from Luminati. It's a VPN network. People install it. They can access other people that installed the software. They use it to watch Netflix from other countries, etc. And we used the open resolvers. We were able to do the query from 284,000 resolvers. And we noticed that more than 20% never retried without EDNS0 option in the query already. So that's the algorithm. So this is the uptake as seen from the authoritative. It's very little, as you can see. This is the uptake for several ASs. The blue line on the top there is Cloudflare. The only one that's incrementally is incrementally deploying Flag Day resolver seems to be Google. Oh, we also looked at ASs that seem to be or moved over to strict resolving, so Flag Day ready, and then returned. So there's only one or two in which we saw this kind of anomaly. So takeaways, yes, lots of authoritatives got fixed and lots of middle boxes were fixed. So the internet became a little better. On the other hand, so if your authoritative dropped EDNS0 queries, you were already in pretty bad shape. And besides Google, and immediately also Quad 9, not much happened or could be perceived from Wipe Atlas at least, and all the other resolvers after Flag Day. Another takeaway is perhaps we should do this kind of impact measurements before the outreach next time. So we've done lots of measurements of things that were broken, but not what the impact would be, or what the impact already was in this case. So I can take questions now, if there are any.
Thank you.
You're welcome.
Does anyone has question? Okay, then thank you again. That was nice introduction. This was a nice introduction for the next session, which is actually a panel. DNS Flag Day 2019 panel discussion led by Petr Špaček from CZNIC. We will have Ondrej Sury from ISC, Todd from Quad 9, Ólafur Guðmundsson from Cloudflare. We have Brian Hartvigsen from Cisco OpenDNS, and we have Puneet Sood from Google Public DNS. So I will probably clear the stage and leave this to you.
Thank you, and thank you for a beautiful introduction, Willem. So this is a discussion panel. In short, we have the major open source vendors and also recursive operators, and the recursive operators are the guys who actually make it a flag day, because as you have seen on the previous slides, the uptake on the ISP level is very, very slow. But thanks to these guys, it is an actual flag day because it will just break on the desired date. So the outline is, we will have a look how it looked 3 months before the flag day, and then I will give a floor to the panelists so they can share their experience, how it looked from their perspective, whether the phone started ringing or what are the lessons learned. And then the most important part of the discussion panel is the question, should we do it again? Was it worth? And if so, what it should be? Okay, so these are the measurements presented during previous OARC in Amsterdam. So the data were taken 3 months before the announced flag day. And the data indicated that the breakage at that point was 5.5% approximately, a percent breakage on the authoritative side. That's counting domains. Of course, not every domain is equal because the number of domains doesn't capture importance of the domain, right? If it's Facebook, Google, and YouTube, we are screwed. If these 3 work, nobody will notice, more or less. You can say, okay, 5%, that's a lot, but it's important to note that 14% of domains in our data set were totally broken and unresolvable even without taking eDNS into account, because there is a lots and lots of domains which are parked or just registered for malware or something, so basically nobody cares. Okay, and we also had a list of known offenders at that point. Again, these numbers are from the October, so we have seen that the breakage is very, very concentrated. So basically we needed to convince just a couple operators, basically 8 operators on this slide, were responsible for 85% breakage at that point worldwide. So okay, this was like, we need to talk to these people, try to get them fixed. It worked pretty well, operators were cooperating, and I think that we as software vendors and operators of recursors have to thank for all the cooperation from the community, be it ISPs or authoritative operators. Thank you very much. And with this introduction, I will turn over to panelists and ask them what's their perceived impact. So, gentlemen, we might start from this side. Ólafur, could you tell us what happened after the February, whether the phone was ringing, customers screaming, sites unavailable, and so on?
Well,
really important
we managed with this outreach effort to get a class of vendors that we have not been able to beat sense into before to actually update stuff. That the load balancers people listen to this.
We tried to break the internet and we didn't. So how it looks like from software developer perspective, Ondrej?
So a couple of things. before Flag Day to see if we saw any differences. Then we rolled out to like one serving cluster on a continental basis in all the continents to see if we saw a change there, and then we incrementally rolled it out. So overall, it was uneventful, nothing broke. However, just like for OpenDNS, for us, thankfully, it was only one large cloud customer. Again, they were not directly impacted by this, but they were concerned that they didn't get enough notice of this, and between them and their vendors, they had to scramble to fix the issue. But other than that, it was uneventful for us.
Excellent. The next speaker is Ralph from NLnet Lab, so the Unbound developer. Please, how it looked from your side?
So we removed the workaround, or actually we released the version without workarounds at the Flag Day, or a couple of days after Flag Day, and since then we didn't receive any issue or bug report from any user, so I guess it's quite uneventful for us. The only questions we got were before the Flag Day from people that did not exactly know what was going to happen. They saw on the website more than what would really happen. So if you didn't have proper TCP support, you would, for example, on the website see a warning, while those people were not impacted in the Flag Day. So I think there is room for improvement in the communication, but for the rest.
Yeah, okay. So to sum up, from what I hear, I gather that there was just no real impact, even though there was a bunch of authoritative domains broken on the authoritative side. So it seems that a lot of craft in DNS is just sitting there, and maybe it breaks some domains, but nobody actually cares about these, or it was fixed in time. So it seems that we can actually fix DNS, and we don't need to just cry and sit. So in the next round, I will ask speakers,
Petr,
what are...
you actually haven't spoke about the experience of the seasoning.
Oh,
Because
yeah,
you are here as a vendor too.
Okay, that's right. I've tried to stay in the moderator role, but yeah, right. I'm the representative for software vendor seasoning doing Not-resolver, and the thing is that our resolver never had that workaround because we were the newest kid on the block. So we just didn't have the workaround. So we basically knew that it's not going to break anything, because if it would break anything important, we would know, because people would be screaming at us, well, bind can resolve youtube.com and you can't, so do something about it. No. So to the next question, what are the lessons learned? Because I think that a lot of speakers told us that, okay, there was some confusion on the customer side. So what can we improve? Maybe we can take it from the Ralph and go back in the row.
What can be improved is, yeah, what I just said, indeed, better communication to the users, not only saying what we will do, also making sure what we won't change. So everybody then knows what will happen. For the rest, what we learned is that we can do these kind of things as long as we work together. We can make improvements to the internet.
Okay. Pass, please, mic on.
Yeah. So I think echoing the same comment, I think we need to explain in terms which are more understandable to customers, because otherwise they feel like, oh, things are changing, it's going to impact me. But we need to explain in terms which normal IT operators understand, that, hey, only this thing is changing, everything else stays the same. And also, I think we have to give them enough lead time, especially for corporate IT, where you have contractors and subcontractors getting all the way through your software chain and making sure everything will work. That can take longer.
Okay, and can you comment on the period of time you have in mind? Is it like 1 year, 2 years?
I don't have a very good sense, but I would say at least 6 months, but I'm just making up that number. One of the things here was more a fault of my fault, in the sense that we took very long to decide. Partly it was because it was a very deliberate decision, but I think Google signed up sometime in early November.
Okay.
And the Flag Day was February 1, so especially with the end of the year holidays, it didn't give enough time to some people, or at least they felt like they didn't have enough time.
Okay, thank you. Brian, please.
Yeah, I would definitely echo most of what was just said there. Like the comments that I got, just quick show of hands, did anyone in this room not know that Flag Day was happening? Right?
Okay,
But
nobody, for the people watching the stream, I don't see any hands in the room. So it seems that room of DNS experts obviously knew that there is a Flag Day.
But if you went outside of our circles, then all of a sudden it became a different issue, right? And the major comment that we got back was that this was something that they kind of felt was being made in this isolated group and not being communicated out to the wider community. And I'd actually thought we'd tried. I thought we'd, but it's one of those, whatever effort you think you need, you probably need way more than that, is kind of how it ended up going. We also made the decision fairly late. We didn't get our documentation in order in a good amount of time, kind of echoing what was said there, and that didn't help, right? So when the customers weren't sure what the impact was, like what does this actually mean for me, they didn't have something to go to. That leads to confusion, that leads to behaviors that you don't want. So yeah, communication would be the main thing.
So I think that the biggest lesson learned here is if you look at this panel, this never happened before, that the open source and the DNS operators work together so closely. So for me, the lesson learned is that if we try, we can really work together, and this is the biggest thing I take from this. The other thing I would emphasize is that what we learned is that we need more communication, but now we have those people attention, so we should use it. So. But we'll talk about it in the next question. So, but now we have attention of those people we never communicated before. We should expand the circle and learn to communicate with them.
Doesn't work.
This one. So again, I think the communication is a good thing. I'll echo the sentiments previously that having both the providers and the software vendors working together, this came together really well. The smoothest actually cross-company communications I've actually seen in quite some time. One of the things though that I think my lesson learned is that again, it's communication, but between the authoritative operators and either the recursive operators or the vendors, that's still a problem. And this is a problem that dates back to the beginning of peer-to-peer, and that how do you communicate to somebody, or how do you know how to talk to somebody who doesn't have any business relationship with you? So the operators of the authoritative servers that were broken, you had to reach out to them, and how do you actually get their attention that something is coming down the line, especially where there are language or other barriers that stand in the way. The next Flag Day or the next event that we try to do as a group, we still need to figure out, I think, a little bit better how to communicate with the far end of the equation, because there isn't a relationship between the entities other than the people on the stage. But the authoritative operators, you're looking in the SOA record for an email address. Good luck with that. Or going to the website and trying to figure out who you need to mail for that particular knock to solve their problem. That, I think, is still, there's some resistance there that we need to figure out how to overcome better. And some of that is encouraging them to come to things like DNS-OARC, but some of them are just not going to be able to reach out to. So, how do we not trip over those things next time when maybe perhaps the change might be a little bit more significant? That's the lesson learned, is we still haven't solved that problem yet, I think.
Doesn't work.
Is this one work? Yes. The lesson learned from this one is we have to figure out what are the leverages that different players in the DNS world have over the vendors of various equipment and purchasing decisions. I know of one case where a customer of a vendor spent maybe 6 to 8 months convincing them to develop a fix, and then it took their own internal IT department many months to test the fix before they rolled it out. So we have to give these players a long time. So I would say we need, after we decide what is going to be in the next Flag Day, let's say we set the date 2 years in the future from that.
Okay, thank you for your lessons. To summarize what I hear, we have heard that the communication is the problem, obviously. We have trouble reaching the people, explaining the problem. Sometimes it was too technical. Sometimes they don't understand what is included and what is going to stay the same, right? And then there is different opinions about how long we should leave operators to fix their stuff. So that's, of course, a very complicated matter. And the most important question for today is if it's worth overcoming the problems and if we can actually make it useful and use the power we got to fix the internet at larger scale again. So should we have the next Flag Day? I can see that we have some technical issues. So the audience in the room, can you raise your hands in the back if you can hear panelists? Okay, it seems that it's workable. Huh? Just one mic. Okay. Okay, so if you can use the portable one. Okay, so now just the binary question, right? Not drilling into the specifics, not asking what feature we should fix or what particular protocol element, but the binary question. Should we try to fix the internet at scale and have another DNS Flag Day or not? So can I have your opinions, gentlemen? Maybe we can just start from Ólafur and go, or if you want to jump.
Hell yes.
Okay.
Yes.
Yes.
Of course.
Yes.
Okay, I'm the last in the line of software vendors, so of course. Okay, that was quicker than I expected. Sorry for cutting you so short, but it was apparently very effective. So now the question is, okay, if the big resolver operators believe that we should do something with the internet, and the software vendors agree, what it should be. For people who are not watching that closely latest development, there is a GitHub repo. The link is on the first line on the slide. And this repo contains issue with some ideas. Of course, it's not an exhaustive list, but that's the primary way how to propose new ideas. So feel free to open it, create a new issue, describe why you think that this is the most important thing to fix, because of course the Flag Day is very costly, right? It's a lot of communication, a lot of time, a lot of effort for testing. So we have to pick wisely and do something which actually makes an impact. So now I will open the mic also for the audience. Microphones are here. So yeah, okay. Feel free to propose your ideas, and then we will turn back to panelists and we can discuss together.
Hi, it's Tail. I'm going to go with QNAME minimization, which would be up there under, I guess, RFC 8020, so we can do aggressive and X domaining.
Okay, aggressive and X domain. Okay, I will be counting on my hands.
Brian Dixon, GoDaddy. I think what we should look at is the time frame, and then how many things would be reasonable to fit into that. I think the more we try and do in the next Flag Day, the better, and give everybody enough lead time to fix the things that are important. I mean, maybe leave a few things out, but try and do as many as possible. The other thing I think we need to think about is there was another major event in the same rough time frame, which was the KSK roll. Whether we want to try and use the attention of the one and the other, maybe commingle those, or at least in terms of making the awareness out there, and use what we learned from this to improve the outreach.
Okay, so the idea is basically do it all at once, or some significant subset, so we don't need to go through all these processes again and again for every single feature. Okay.
Matt Poundset, not so much to make a suggestion, but to make a comment or reply to something that somebody said on the panel. There may have been gaps, but don't sell yourselves too short on the messaging to people, because in my regional nerd Slack and mailing lists and things like that, people who know I'm a DNS guy were asking about it, and so obviously the word was getting out there to at least some people. So yeah, I think that worked out really well, or maybe it worked fairly well anyway. As far as suggestions, I think trying to get maybe if we want to do more of these. I think it might be a good balance point between having fewer flag days with more stuff in them, but not going overboard, right? People need time, particularly software developers need time to get all this stuff together and get it organized. So trying to bite off too much on each flag day might be a bit of a problem.
Okay, thank you.
Paul Hoffman. I sort of agree with Brian. I like the idea of combining them.
Sorry, could you speak into the microphone?
Sorry.
I have trouble
I sort of agree with Brian in that combining them, either that or we're going to have like every 2 years, and now it's 10 years out before we get to some of them. I'm concerned about QNAME minimization. As folks here might know, I'm the co-author on the QNAME minimization BIS draft, and we can't get any damn traction in DNS-OP from you folks. So please don't put things on the list unless you intend to work on them in public so that we can actually have a spec ready first. And also going back to a few things that people had said about communication, I got calls, just ICANN is the DNS place, so press folks call me about Flag Day. They had no idea who else to contact, and some of you got calls from press folks that I had sent in your direction. That's silly, because in fact, if they had gone to our press office, that would have been weeks of delay, and who knows where. So if you're going to do another Flag Day, have at least an email address that is monitored by a bunch of y'all who, to answer, and make sure that that is prominently displayed. Yes, it's going to be a pain in the butt to do, but most of the press, I think that the two major articles I saw in the press were sort of related to me, and I wasn't part of this. I was just like passing them off to you. So that's not a good sign. But the elephant in the room is communication with the resolver operators and the authoritative operators. If you're going to be doing something that they need attention to, as we know from the KSK rollover, talking to resolver operators, finding them or whatever, is really, really hard. And we at ICANN didn't do that great of a job. We tried real hard, and that didn't work. I have no idea how you would get in touch with them. It might be worthwhile to drill down a bit on that, especially because in the case of Flag Day, you folks, many of you folks are in fact vendors. And you do know who your customers are. Even if you don't know who they are, you have a communication channel with them. Getting your own list of operators, not just, oh, you're our user, but an operator who's using our software would be a huge benefit before you do a next Flag Day. Barring that, some of these, you really will see, I believe, more breakage than you would have seen with EDNS.
Okay, thank you for feedback.
You're going to have your own customers coming back complaining if you don't do that first.
Yeah, thank you very much for your opinion.
Rubinsky, unique.pr. Just one comment that sometimes we solve our problems and create problems for other people. Most of the cases I followed up were cases where V6 wasn't working, and that led to a number of domains losing V6 glue records, where they have those before. So we now made the transition for a DNS recursive without V6 much more difficult because of that. So we might want to be cautious in those cases where, hey, we really made things simpler for the DNS community and made things harder for the IP addressing community. There is one issue over there that's quite likely to cause that, which is UDP fragmentation, mandatory TCP. So we should think carefully before
Okay,
doing that.
could you clarify what do you mean exactly, because I didn't got it. Are you saying that some people had a problem with the tool, testing tool, only on IPv6, so they withdraw the IPv6 address?
Exactly.
Okay, so it's like more hiding the problem instead of solving it, right?
Yes, but most of them actually worked because of dual transport. So, but their response to this problem was turn v6 off.
Okay, thank you. I didn't consider that as a solution.
Hello, Paul Vixie, author of the eDNS0 spec. It was a bad spec, and we have to keep that in mind when we're counting the lessons we're learning. Bind at the time had a very large market share. There weren't a lot of other implementations out there. Therefore, we, mostly Mark Andrews, were the first to implement this. And the RFC itself made two now ridiculous, but at the time seemingly reasonable assertions. One, that you'd be able to tell when it wasn't working. You would get some sort of an error signal. And the second is that there would be a gradual adoption to the point where it was opportunistic, and you would always try, you'd give up easily, you'd try again later, and someday you would just stop having to give up. Those were both ridiculous assertions. So we were in a pretty tight spot because we wanted to implement this protocol, but the tipping point had not been reached. In other words, any problems caused by implementing this protocol the day the RFC was published would be seen as our problems. Bind has a bug. It will no longer work with a vast amount of the content. There was a tipping point, and it did not occur this year. It occurred probably 2 or 3 years after the RFC was published. There was a tipping point where we could have removed all of the workarounds, and the problem would not have been seen as Bind's problem. It would have been seen as the Internet's problem. But we did not recognize that tipping point. In fact, Mark Andrews has been fiendish in his pursuit of new workarounds to find, oh, maybe if we try eDNS with a 512-byte buffer size and all the rest of the ideas. None of those were ever standardized. We did not reissue the eDNS0 spec every time another workaround was found. It was eventually reissued to correct all kinds of defects. But in fact, none of the workarounds that were pulled out were ever a standard, and could not have been made a standard because we would have been laughed out of the room. So when we're looking at lessons learned, we should say, put it in and declare that after a certain period of time it is mandatory to implement, and anybody who complains after that time, 2 years seems reasonable, can be told that it is their problem and we're not going to have a long tail on the thing they refuse to upgrade, and that's their problem, not our problem, after date certain. That's the lesson learned.
Okay, thank you very much.
Of your list, I want to say that we have a UDP fragmentation issue because v6 doesn't work with IP fragmentation, and what we need to do is fragment everything. We need to fragment every single v6 datagram, and anyone who cannot hear it because they don't speak the fragmentation protocol should fall back to v4. I don't want mandatory TCP. I want mandatory fragmentation until it works everywhere, because we have to make the problem hurt where it's happening, not hurt the early adopters. Thank you.
Thank you. I will ask other people in line to be brief, so our panelists have a chance to comment on that as well. Sorry, it's nothing personal. Go ahead, Kathy.
Kathy Elmond, ISC. 4 things in that case. The first
could
one,
you speak, please, closer to the microphone?
4 things.
Thanks.
The first thing is suggestion that we work to reach the authoritative server operators via the registries. There was some attempt to do that over Flag Day, but it wasn't very widespread, and some of the communication ended up going to the wrong consumers from the registries, so we need to be a bit clearer on that. So that's point 1. Points 2, 3, and 4 are things that aren't on the list. but they're basics, they're not new stuff. And it continues to be a problem that some implementations will support some brokenness and some implementations won't. So for example, delegation from authoritative servers, but the name servers that they delegate to give a different set of NS records which are not reachable.
Okay.
Some implementations support that, some don't, but it becomes a difficult operational issue. Things like when you query servers for the A record, you get an answer. When you query them for the quad A, you either get no answer, or you get an NX domain, or you get something that quotes the wrong authority. I think that's 1 and 2, or 3 and 4 at the same time.
Okay, it will come back.
Just basic stuff, not even new stuff.
Okay, thank you.
Martin Levy, Cloudflare. Myself and I think a few other people in this room lived through the other flag day, World v6 day. We did 2 of them. And I just want to provide a little bit of feedback. The level of PR, the level of involvement, far, far greater than was done for this DNS flag day. So when you do the next one, don't do, well, my argument is don't do many, but be careful. Get as much out of it as you can, but bring the PR engine that we actually have experience with in this industry, that we did with V6, the flag days for V6, and really go with gusto. You get into The Economist, you get into the Evening News, you get into basically, well, outside of this room is, I think, the issue.
Yeah, that's an excellent observation.
It takes time and it takes people, and there is lots of expertise, whether it be Internet Society or others that have got this.
Thank you. Ralph?
So just on another data point, when we rewrote our resolver from single-threaded to multi-threaded in 2014, we removed all the DNS kind of workarounds, and this has been running in production at Comcast since 2016, so I agree with you that, I mean, it wasn't an issue a couple of years ago, and it could have been done earlier. Another thing, QNAME minimization is not on there, and that is good because I don't think it's a good idea. What is on there is RFC 8020, which means NX domain, nothing is underneath it. That is a good idea. However, I think the stuff to focus on going forward is that we have to get DNS over the underlying network, and that's UDP fragmentation, mandatory TCP support. I think that's the thing we need to work on.
Okay, thank you. And now I will give a chance to panelists to speak up. Gentlemen, whoever grabs first. Okay, Ralph.
About the 80-20, so what we do in Unbound is we do QNAME minimization by default with fallbacks against the NX domain on antinom terminals. If we now start to enforce the 80-20 always, that means that our users will stop using QNAME minimization. And I'm not sure if the privacy loss here outweighs not having those fallbacks. So I prefer to not enforce 80-20.
Okay, so if I rephrase that, you are saying that we shouldn't be pushing for features or protocol elements which would cause the people to disable privacy features because it's easier than fix the stuff, right? Is that right?
Exactly. So if everybody here would do QNAME minimization by default without fallbacks, then I'm happy to join. But as long as not everybody does it, then some implementations will be hurt and other ones won't.
Yeah, that's exactly the coordination issue. Once vendors and operators coordinate, we can push for more things. Okay.
Ralph, I'm just confused on one thing. And maybe I'm the only one, and I'm sorry, but what was the relationship between QNAME minimization and case folding?
If you do QNAME minimization, you hit a lot of empty non-terminals which you otherwise wouldn't hit. So if you get an NX domain back there, you store that one, and you won't be able to resolve the rest of the domain anymore.
Yeah, but the case folding
it's interaction
comes in
between workarounds, let's say. Yeah, the workaround for random query name minimization.
I just had an Ed Lewis moment.
Yeah. It's interaction between workarounds, which is one of the painful things in the DNS.
Hi, this is Shuman Huck. So since my name is on RFC 8020, I feel obligated to say something. So obviously I support it if you adopt it on the next flag day with caveats. So I agree with what Ralph said, but I think the tactic that Unbound took with their 8020 implementation, which I believe is called harden below NX domain. That is on by default in latest versions of Unbound, but only selectively, only for signed zones.
Yes.
If you do it only for signed zones, I think you will indirectly solve the QNO minimization NX domain for empty non-terminal problem, because in signed zones, it is kind of unlikely to see you have that problem, because if you implement DNSSEC properly, you are going to answer correctly for empty non-terminals. At least I haven't seen no counterexample of that
exactly.
case.
I think that we shouldn't drill into implementation details right now. Of course, the RFC has security consideration section, and sure. That's something to consider before deciding. So, does anyone from panelists has his favorite feature or protocol violation to fix?
I don't know that I have a favorite to fix. I was just going to add to the comment there, which is this is one of the cases, I think, if the empty non-terminals, where it would almost need to be a two-step flag day, right? Where first the authorities all have to get something out, and that software needs to be out there so that there's that groundwork in place, so that those of us operating recursive servers can now be comfortable that it's out there, right? It's not one that I think can necessarily happen just, 2 years from today, we're going to do it, because there's no groundwork that's there to support that.
Okay. Yeah, some of the features are definitely more complicated than others because they require more changes. Yeah, so I can see that.
So, I have a couple comments about the next flag day. I think we should do it every year, and I would like to adopt something like TikTok model, where every year, even year, we do something small, and every even year we do something bigger, just to keep the attention of the operators to that's the thing that's happening. So for the next flag day, that would be next year, let's fix something that's not really broken. Which I don't know if that's on the list, but let's think of something that we could announce and really not break anything, but to keep the attention about that the flag day is happening. And then when we say QNAM minimization, I'm in favor of that, but I think what we really mean is the prerequisites for the QNAM minimization. So let's do the flag day for the prerequisites, and because I don't think that the QNAM minimization should be mandatory on the recursive side. It should be still optional, but there are two modes, like the strict and the relax, or I don't know, it's called an unbound, but basically the flag day should mean that you should be able to turn on QNAM minimization in strict mode and not break anything, and that requires the prerequisite. So it might be it might take longer than just one flag day to get there, but let's get there. There are more stuff broken than just an NX domain for non-terminals. There's more, especially load balancers are really bad at that.
Yeah. It seems that we are avoiding the hard issue, and that's the UDP fragmentation, which Paul Vixie mentioned. How does the operators feel about TCP? Are your infrastructures ready for, handling more TCP to the authoritatives? Let's say if we drop eDNS buffer size to some small value, so we can, talk to the authoritatives from resolver and be sure that there is no fragmentation, so we don't have to handle timeouts caused by UDP fragmentation or UDP losses and so on. Go ahead, Ólafur.
So we are definitely in favor of more TCP, partly because it deals with the packet loss issues and fragmentation, and as well as we look forward to doing TLS2 authoritatives, TCP is a good half step towards that because it's harder to forge responses, as well as it exercises a bunch of the behavior you want to test for TLS, like scaling, maintaining state between the recursives and the authoritatives.
Yeah, that's actually an interesting observation, that fixing DNS over TCP on the authoritative side might be kind of preparation for future development, like doing DNS over TLS to the authoritative side. That's interesting one. Ólafur, you wanted to come? Okay, it was already said. Okay. It seems that we have still a couple of minutes, so I have a backup slide for you because I just was bored before the Flag Day.
So Petr, maybe well, can you get back to the list?
Of course.
And can we like show of hands for the items, maybe like to get a feeling of the room, like, just really quickly?
Yeah, maybe. I will.
So let's say for the Flag Day in 2 years, so there's enough time to prepare for it. No, not next year, but
okay, in 2
for
years from
something
now.
bigger for 2021.
Okay, so okay, it's yeah, of course. Okay, so pick your favorite features. You can pick more than one, and I will ask gradually this very room to see whether there is some strong opinion about one of these on the list. So does anyone actually favor 0x20 query case randomization? Okay, I can see one hand, and in the panel, like 2.5, 3 hands. Okay, 3 hands in the room. Okay, the next in the list is UDP fragmentation issue. The question is, what do we do with it, right? It can be mandatory TCP and the authoritative, so let's start with that. That's easier to imagine, for me at least. Okay, that's like, I would say, 1/4 of the room, or maybe 1/3, and like most of the panel. And then the other approach is forcing UDP fragmentation all the time, and just breaking the networks which don't handle UDP fragmentation. Where is Polvixi? I expect at least one hand. Yes. Okay, that's interesting. I don't see anyone who would favor this using force on network operators. Okay, then we have RFC 8020 and all the issues involved with that, right? I can see one hand, 2 hands. Oh yeah, actually I like it too. Okay, that's, I would say, like half of the people who wanted the TCP from my look, my position. And then the greasing DNS option, let me explain. That means that the resolver basically sends unknown eDNS option just to make sure that the request is not dropped and it's, you know, the answer gets back without the option. So it basically protects the protocol from ossification, because whatever which would start dropping queries without the known eDNS option, it would just die. Okay, it doesn't, okay, 1 person, 2, 3, 4, okay, yeah, that one is easy to do actually. And forcing eDNS version negotiation, that practically means that the resolver would send a query with eDNS version 252 or some other number, doesn't matter, which would force the authoritative to respond with badwares, I don't understand this, try eDNS version 0, and of course that would impose round trip time for every authoritative, extra round trip time, which is horrible. So is anyone in favor of this? No, okay, 1 person, okay, 1 radical in that corner. Okay, panelists, do you want to add something to this? Now it seems that in the room the sense is that fixing UDP fragmentation issue one way or the other, or preferably the TCP, is the thing to do. Speaking of measurement, from the latest measurements, it seems that today or a week ago, the breakage on the authoritative side is about 7%. And the interesting thing is that like 70% of the breakage is one operator, and counting first 10 DNS operators gets us to 90% of the breakage worldwide. So if we could convince these 10 or actually 9 organizations to fix their authoritatives, it would just work. Unfortunately, we are out of time, so we need to discuss in the hallway. Thank you for your attention, and thank you, panelists, for your time.
I have a question of clarification. I didn't know whether to raise my hand. The 0x20 draft specifies a fallback.
Yeah, that's right.
So are you suggesting a flag day where we implement it without the fallback, or are you suggesting a flag day where we implement it?
That's up to the discussion, yeah. I mean, these are just wild ideas. Of course, everything needs more discussion. So, okay, thank you for your attention, and I think that we can look forward for more Flag Days.
Thank you. And the last presentation of today's block is by Ólafur. So Ólafur will talk about the road to the ultimate stub-resolver. So please.
Sorry, my glasses are dirty, so I have to take them off. Okay, this is basically two talks in one, because I realized as I wanted to, what I wanted to talk was not exactly going to work. So first, I'm going to talk a little bit about the history of stub-resolvers, because that gets us to what is happening. Clock. Oops. So stub-resolvers came into existence probably around the time the first Berkeley implementation of Unix was done. And we are somewhat living with that. What the stub-resolvers do, well, they look up the recursor from the configuration, they set the RD bit on the query, and they wait. Okay? They made some assumptions in those days, which made total sense. Well, you had one network connection. There was only one namespace, i.e. the internet. The host had only one address, because who needed more? And it was always in the same location. Well, POSIX came around and they created a more standardized library, but it was quite limited. It only supports a few dumb types. And then people started creating object-oriented libraries that were basically a variant of that. And nothing supported unknown types. So no path forward. We started getting better libraries around 2000, maybe a little bit earlier, maybe a little bit later. And they also started adding things like you could do interactive queries on the fly without using the dig program. But they did not influence the standard operating system libraries. Getting changes into the operating system libraries has been basically impossible. How long did it take to get many of these operating system libraries to support the Quad A type? Are we done is the question that we should be answering. Are there some operating systems today that are shipped that don't support it? I don't know. In the 2000s, we started getting even better, that actually allow you to build real services that can talk over the net. Some of these can be used to write their resolvers, authoritative servers, or high-performing applications. And a number of applications have integrated those. So let's go back. What is the problem that the stub-resolver is causing? Basically, stub-resolver, as provided by the operating system, provides nothing besides an interface to ask a question. It has no memory, so if an application asks, or two applications ask the same question, there's no caching. They repeat the queries. Oh, that's good. But frequently, all they do is they always ask the same place. So if one of the provided resolvers is not answering, and it happens to be the first one, you have to wait for a really long time before it switches to the next one. Well, so the summary is, we're living in the past. We're living with this. And this is affecting many applications. Browsers want to look up various new types that are out there, like CAA records. SRV records are hard to use in many environments, and we can't get them through the operating system. We can't get them through middleware. We can't them. So there has been a certain reaction to this from certain communities that is disproportionate. And yeah, the crap stuff where we have makes life horrible for applications. And that is partially not our fault. It is whoever maintains these libraries. At the same time, we have to look at this, that not everything on this internet we have is equal. The computer that sits on your desk, it's close to what it was in the 1980s when the DNS came around. Servers, they don't move around, but they may have lots of addresses and deal with lots of networks and see lots of traffic. Laptops, well, who here does not have a laptop or tablet to take around? They go around, they connect to random networks all over the place. Your phones, well, they talk to everything. In the DNS community, we have tried to provide functionality that makes it easier for devices to be safer when they are on the road. For servers and desktops, we can put the resolver on them, and if it works when we fire it up, we can be not quite certain that it keeps working. Mobile devices, when we go from one network to another one, all bets are off. DNSSEC Trigger was an attempt to provide DNSSEC resolution on your laptops. It has gone through many revisions. It has run into many issues. There are lots of things that have been fixed, but it's still somewhat painful to use. On the mobile phones, a number of applications have come that allow you to use various of the Quad 1 or Quad 9 services over a secure connection. But they still fail in a number of networking environments. We heard yesterday about an incident where the window that you disable these secure resolution mechanisms while the device is signing up for a random network was long enough for the internet connections to be hijacked. So the devices are not supporting secure operations, the environment is not, so what do? We have to think about that there is not one solution for everybody. Does the Quad 1 app, is that the new Stub-resolver on the phone, or is the thing that it talks to lower on the phone, is that the Stub-resolver? But, so if I want to solve another problem, if we look at this box, from now on, I'm only concerned about the servers. That's all I care about. That is what I'm trying to address. How do we speed up resolution for a farm of servers? We want to provide services as fast as possible or people go away. It's the happy eyeballs. Cloudflare is, to a large extent, a CDN that acts like a reverse proxy. We do all kinds of funny things. The eyeballs talk to our metals talk to various devices and services that the customer has specified, and we fetch information and deliver it. Many of these origins have been specified by names, so we have to resolve those names fast. We also want to be able to adapt to changes very fast, overcome problems, so we don't believe long TTLs. And that is sometimes good, sometimes bad. When the Dyna attack happened, shared customers suffered badly. And I'm sorry about that, but things happen. Cloudflare has gone through its 9-year life through a number of versions of resolution on the metals. We started as a small company. Our original colos that got deployed had counted on one hand number of servers, and now they have grown to much larger ones. And in the beginning, as the cheap, quick startup solution, use Quad 8. It works. Well, yes. Then, okay, it doesn't work. We need to put the resolver on the metals. We put our DNS. At some point, that got replaced with Unbound. I'm not exactly sure why that happened. When I started working at Cloudflare almost 5 years ago, that's the state, and one of my first tasks was to make that faster. So we deployed a more tiered version of Unbound to make it better. Why is running a recursor on every metal a bad idea? Well, we have bad costs. Those are the reasons. But the biggest one is it's really hard to diagnose problems. because you have to know exactly which machine is involved in every transaction. So if you do a transaction against one machine, it works. If you do it against its neighbor, it doesn't, because they have inconsistent DNS state. Customers complain about that, and also the advanced features like prefets, they don't work, and yeah, and we are seriously hostages of slow authorities. The resolver was basically all the time in what I call discovery mode, i.e. it is trying to measure what is the distance to the various authorities for the domain I need to talk to. As we saw earlier today, resolvers like to know this, and sometimes they like to focus in on the fastest ones. I want mine to really focus in on the fast ones, because that makes system faster, we give out answers, we get better customers, and everything. There is a debate in the DNS community about safety versus speed. Some people that implement software or operate it think that by scattering queries, you are doing a good thing because it makes it harder to poison you. At the same time, we could argue that is a false argument because it gives the attacker a longer time to send you a stream of answers. But basically, I think it should be up to every operator to select the mode they have, and Unbound has implemented recently, after some prodding, to the ability for end users of Unbound to select the operating mode they want. What we did was we basically designated a limited number of machines in every colo to do all the recursion. Everybody else was doing forward first. And forwarding is used a lot in the DNS world, but it is frequently ignored when people talk about the DNS. When you are, for example, in all of your cable modems or DSL modems or whatever you have at home, I can guarantee there's a little piece of software, most likely DNS mask, that is acting like a DNS responder for your network and then forwards every question up to the recursor farm of the ISP. When we designed this system, we made a few mistakes because we were thinking about avoiding not having any recursive resolvers. And one of those was to have the uppers running on any cast addresses that were local to that network. We also changed our TTL policy so that the upper has a much higher TTL than the lower, and we did this mainly to encourage prefetching. And prefetching and changing the TTLs gets into a very interesting mathematical problem, because depending on what TTL the DNS operators pick, and with the ones you pick, you can end up in very strange harmonics. So some customers or some sites see very good prefetch rates and others see none. The basic answer is use prime numbers for max TTLs. So this is a diagram of what it looks like. Basically everything on the side of the purple or the blue line is what happens in each metal, and then there are these. What was the effect? Okay, well, to deploy this new system, we had to take the colo offline, update all of the machines, and then bring it up. So that is why there is a dark spot in the middle of this. The greener the color, the better things are. So what you see here closer to me, those are when we run the resolver in every machine. This is combined for the whole colo. After it, the machines were really happy, and you see all of the heavy work has gone over to the upper. So we improved performance a lot. So this was a good thing. We had all kinds of problems. Upstream selection, well, it's not under control.
we kept running into problems that some of our uppers did not get any questions. And this turned out to be that Unbound was at the time conflating error codes that were non-positive to a problem with that device. The device was answering, but it was not giving positive answers, therefore it was bad. And once in a while, we saw problems with the forward first kicking in when we didn't want it to kick in. And yeah. And depending on when you are in the world, your probability of triggering these conditions is different. So you can run all the tests you want in your location, like in California, and you never see any of these problems. You try this in India, things happen. One of our interesting things was that surf fail. When we did the DNSSEC standard many years ago, we said that surf fail was a very good thing to return when we did DNSSEC validations. Well, surf fail was also used for a few other things and blah, blah, blah. Some people were saying, no, you shouldn't do it. We should define a new error code. For some reason, we failed in creating a new one. And we started having various problems because there were issues happening. So I counted how many different places Unbound was issuing surf fails. That was 14 different places for 14 different problems. I'm sure bind and not resolver have exactly the same problem. And the logging that came out of the system was not clear on which one was setting it. Unbound people, they went and they fixed it basically overnight once we pointed this out. It was great. Timeouts. We're talking here about two DNS entities talking to each other, and they are within a millisecond of each other. Where Unbound was using the same logic as it was to talk to between DNS entities that could be a second apart. And that did not work very well. Not their fault at all. Yeah, I mentioned the anycast can happen. As we were doing this, we had to do all kinds of integrations with our other infrastructure. And getting things into our logging infrastructure was a challenge, but Pavel got to deal with it, and we ended up using Pika for some of it. But the issue we ran into is when we started the design, we assumed we would be able to get to 80% cassette radio. We couldn't. We were in the mid-70s, and we couldn't get any higher than that. And that got us to worry about things. We also ran into an issue that we have not necessarily talked about, is that if the key roll would have happened in October 2017, we would have suffered. And the reason is what I call the container problem. Our Unbound uppers are doing DNSSEC validation. They moved between machines once in a while, and the new machine started RFC 5011 when it got booted. So yes, that got fixed. I may have complained about Unbound, but it is not just Unbound. Any DNS resolver we would have used, we would have had similar or different issues. It is a really, really good software. If you're operating in a hostile place where network connectivity is not very good, there are high losses, there are long distances, Unbound is fabulous. It never gives up. You may not like how long it takes, but it gets you the answer. And that is what you ask for a resolver in some cases. Also, Unbound hid from us on the CDN side all of the EDN crap that got fixed on Flag Day. So we did not realize how bad the situation was until we got there. And what the breakage we saw from Flag Day on the CDN side is much bigger than what we saw on the consumer resolver side. So, what did we do? Well, we came up with version 4. We went through a very extensive process of selecting. We tried everything. Okay, it was not. We tried all the resolvers. We thought about writing our own. Then we said, DNS dist, it's different. It's doing something, but maybe not. So we also went through what were decisions, we undid them, and we wanted, the thing we had realized over the time is we want to be able to apply policies to our resolution. So we want something that can apply policies. DNS-dist has an enormous set of good features that it designed for load balancing among slower resolvers or authoritative servers. It does it in a really good way. It has a good understanding of what's going on. It has all kinds of features that we are not using, we might use. It is, for example, if you're thinking about providing DOT service and you don't want to load down your own DNS authoritative server, think about putting DNS-dist as the terminator for DOT. Might not be that bad. It does exactly what we wanted to do. Basically, monitor the health of the uppers, send the question to them according to a policy we set. So our new design is this we have here. But you see there's a little red box there. That is the box that allowed us to bring the caching ratio up. By starting to look at the query names, we can start directing them to a smaller set of uppers. And that allows us to concentrate things, and that brings our caching up. So the process we went through was very extensive. We tested, deployed, ran it. There had to be a total feature parity on day one. From the time we went to step 3 until we went through step 5, it was about 9 months. Okay, the good thing was we didn't have to turn off a location when we bring up DNS-dist. We just exit a command and things went. Before, we had to bring up the number of uppers in certain locations up, even though they're not active. This shows the query volumes that each one of them were getting, and you see we have a few that got a lot, and then it just went down. The thing that I get yelled at if it gets bad is how long does it take to look up the names of our origins? And that is what we call CNAME flattenation. And you saw it collapsed when we did this. Here is a better picture of a whole colo. This is what effect on uppers. They got better. And if you look in the upper corner there on the left, you see our cache ratio went up a lot. I should have had this as a reverse logarithmic because the higher percentage you get of cache ratio, the better it is. The effect on our main DNS consumer, the RDNS, is immediate reduction. We had to go into the total extremes to not see a drastic drop, and that is the leftmost on the bottom. Yep. Then we had a further change. We decided to we did a parallel project where we looked at increasing our max TTL in the uppers, and we made this big change from 90 seconds to a little bit over an hour, and we reduced the DNS traffic a lot, no complaints. So if there are any TLDs out there that are saying they can't lower the TTLs on your delegations because you're going to get so much extra query traffic, I have news for you. You're already getting the traffic, because anybody who's working at speed on the resolver side does not believe long TTLs. Faster, better, no issues in the deployment. And I have to say, we're very happy with both of the software we're using. We keep using Unbound for doing the recursion. It does that great. DNS-dist is a really, really good code for what it does. So take a look at it. And both of the teams that maintain those are really good. We're very happy with them. You have a mic.
Thank you, Ólafur. Yeah, please, questions.
Hi, Matt Poundset. I just have a clarifying question about one of your graphs. You had one for cache efficiency. Is that just your cache hit rate?
Yes.
And I was just curious, I saw one of the slides go by saying NAT must die, and while I appreciate the sentiment, I was wondering how that figured into your architecture.
Sorry.
One of your slides went by on the right-hand column that had like details of each of the main slides. It said, NAT must die.
Yes. NAT must die. I skipped that. Is basically when we deployed the tiered unbound, we NATed from port 53 to port 55.3 for every service, and that was a really bad idea. So now we have every application that runs on the edge talk directly to the the DNS dist over a different port, but system services keep using the old DNS port. Okay. Thank you.
Thank you again, Ólafur. So, a couple of announcements before we go all to the social event. Please fill in the survey for day one. We are really interested in the feedback. We are also still looking for lightning talks. There have been many submissions, so please send your ideas to submissions@dns-oarc.net. Also submit your PGP keys for the signing party at pgpsign@dns-oarc.net. Please send them by midnight. I don't. This one. So yeah, please submit your keys. For the social events, please collect your tickets. There are still some people who haven't collected them. You need them to get to the boat. You will get the information about the boat outside of this room, and the boat leaves at 6:20 sharp, so be there in advance. Today, 151 people turned up, which is great. And we, of course, would like to thank you to the sponsors, to ICANN, APNIC, DiamondKey, Security, THNIC, and .ri. And that's it. See you at the party. And tomorrow at 9, we start the next session.